HAZLOC Installation, gas atmospheres. In this presentation, we're going to be looking at the requirements for Zone 0, 1, and 2. Each of these zones will be divided into the equipment permitted, the wiring methods permitted, and the sealing requirements, as well as some other items not similar to each installation. We're going to start in Zone 0 at 18090. 18090, Zone 0, is the most hazardous place on Earth, and we can imagine this as the center of a propane tank. It indicates that intrinsically safe circuits only are permitted, and when we go to Table 18, although it may not appear to be true, it is. All of these different specific types of protection are actually intrinsically safe, and due to that, they are permitted in Zone 0. 18092, Subrule 2, indicates that a cable that's rated for hazardous location with non-intrinsically safe circuits can pass all the way through the zone if there's no terminations inside it. In addition, a conduit of rigid metal conduit with no intrinsically safe circuits could pass all the way through a Zone 0. However, there cannot be any couplings or connectors within this section of conduit. 18094, Subrule 2, indicates when we are bringing a rigid metal conduit to a device, the device is going to be intrinsically safe, and because of that, we don't need an explosion-proof seal. Only a flammable fluid migration seal is required to prevent the migration of flammable fluids through the conduit. In the same way that if a cable is used, flammable fluid migration seal would be required. Zone 1 is not as hazardous as Zone 0, but still pretty dangerous. That'd be the area outside the tank within a fairly close distance. Now, there's lots of hazardous location equipment permitted in this area, and Table 18 is used to reference. Here are all the different things that could be installed, or labels of equipment that could be installed in a Zone 1 location. Here's some example of a motor nameplate, and you'll notice that it even has information on it regarding the EEX. So there's explosion-proof, D, flame-proof groups. Those are the gas groupings that it is acceptable to be used in. 18102 discusses wiring methods for Zone 1. They are primarily tech cable, which is hazardous location rated, and threaded rigid metal conduit. 18102, Subrule 2, indicates that explosion-proof, flame-proof fittings and joints shall be threaded for connection to the conduit and cable glands. And that makes sense. That's how all of our connections are going to be made to explosion-proof gear. There are two different types of threads that are possible to find on equipment. If they're straight threads, minimum of 5 engaged, and if they're tapered, a minimum of 4.5 engaged threads. I don't know who's going around and counting that half thread to make sure you have 5 with straight threads. I would read Rule 18102.3a and 18152.3a in Appendix B for further details on threaded rigid metal conduit. 18102 Subrule 3 indicates that when we're using tapered, running threads are not used. Now, they're not permitted. So we've already looked at that. We know why that's not permitted. Metric straight threads, it says, need to have a tolerance class of 6G, 6H. Now, this is really just an ISO, International Standard Organization requirement tolerance class. And really, it just means that it's a really high tolerance, so very precise threads. Subrule 4 indicates when we have threads of different forms, we need to get adapters, and the adapters can then adapt a straight to a tapered thread. Subrule 5 indicates conduit and cable entries going into increased E safety enclosures shall be made so as to maintain the degree of protection provided by the enclosure. So increased safety E enclosures are explosion protected IEC enclosures, and usually they're a plastic enclosure like this. They look like a weatherproof enclosure. To contrast that, a standard explosion-proof enclosure will have a thick wall with minimum 5 threads engaged, and this ensures the enclosure remains weatherproof after the conduit is installed. If you were to attempt to install rigid metal conduit into an enclosure like this with 2 lock rings, obviously the IP rating of the box would not be maintained because water and anything could just get in through the gaps. In this situation, a Myers hub will be used, and it allows for the connection of rigid metal conduit to thin-walled, non-threaded enclosures while still maintaining their ingress protection. 18102 indicates that cables under several 6, cables shall be installed and is supported so as to avoid tensile stress at the cable glands. Now, obviously, this makes sense on many levels. Subrule 7, if we were to use intrinsically safe wiring methods, it says that we're exempt from subrules 1 to 4. And what this means is that since IS wiring is incapable of ignition, they can be run in raceways or cable types that are not listed in subrules 1 to 4. This offers more flexibility and reduced material costs. Appendix B 18104 provides some good, useful information regarding seals in hazardous locations. It says it's important to follow the manufacturer's instructions closely. Seals will not function properly to prevent the transmission of an explosion beyond the seal if not done so. Improper sealing has been the primary factor in a number of explosions, resulting in loss of life and major equipment damage. Users are reminded that only the sealing compounds specified in the instructions may be used in the seal. Use of other manufacturers' compounds in a seal may compromise the integrity of the installation. Well, let's take a look at what the requirements are for sealing in a Zone 1 location. 18104, Subrule 1, Item A, explosion seals provided in a conduit system where the conduit enters an explosion-proof, flame-proof enclosure that contains devices which produce ignition-capable arcs and temperatures. So, ignition-capable, that means when we look down at this diagram, this is a switch, an explosion-proof switch that would produce arcs and high temperatures. Same with this one. And because of that, we need to have a seal on the rigid metal conduit, which is entering into this explosion-proof enclosure. This is a little bit different. This is a junction box where we would have splices and taps. Now, splices and taps do not produce ignition-capable arcs or temperatures. And because of that, these sizes of conduit do not require any form of explosion-proof seal. If we go further, item B indicates 53 trade size. This size of conduit does require a seal no matter where it happens to be installed on the explosion proof. So it says here, enters explosion proof, which produces ignition capable arcs, temperatures, or is 53 trade size or larger. So if it's larger, 53 or larger, regardless, it needs to have an explosion proof conduit seal on it. When conduit explosion seals are required for an enclosure, they shall be located as close as practicable to the enclosure or as marked, and no further than 450 millimeters from the enclosure. So this distance is mandated. It always needs to be close. And that's important because it prevents the pressure piling effect from increasing as it passes towards the seal. Now, what will happen under 18104 if we're entering into non-explosion proof enclosures? Well, if we go back, I'm going to go back one. So I'm going to go back one slide and we're going to take a look at 18104 and we're going to look at Subrule 1. It says explosion proof seals are provided in a conduit system where the conduit is 53 trade size or larger. Okay, so 53 trade size or larger. And there's no indication when I read that sentence to you that that has to do with an explosion proof enclosure or non-explosion proof enclosure. It simply means that if I have a 53 trade size or larger conduit, I need an explosion seal in it. So let's take a look. This one here, 18104, and now we're looking at an increased safety plastic IEC type of equipment. All of these items here are IEC plastic. They've got all sorts of fancy tech in them. They are not explosion proof. This is a big old junction box, and this is a 53 millimeter rigid metal conduit coming into it. And because of that, I need an explosion proof seal. Now, the explosion proof seal is really just here to prevent the migration of gas down through the system. Subrule 3 indicates that we need to ensure there are explosion proof seals when the conduit crosses a Zone 1 boundary and terminates in a Zone 1 area. So we're going from non-hazardous to hazardous. Item A indicates the seal is installed in the conduit run within the Zone 1 location or no more than 1 meter external to the Zone 1 boundary. So it states you can really put this anywhere, and this is any size of conduit. I'm just using a 41 millimeter as an example. So rule states no maximum distance here. It simply has to be somewhere inside the hazardous location or no more than 1 meter away. Now it has to be an explosion-proof seal, and all of these would be considered acceptable. And we need to also consider that there cannot be anything interrupting those sections of the conduit. So item B indicates the conduit run shall be uninterrupted between the explosion seal and the point of termination and where the conduit crosses the zone 1 boundary. So no fittings, no junction boxes, no enclosures, no devices in this area. Using equipment that is not explosion proof still requires the same placement. And that's because, again, we are just trying to prevent the transmission of gas from the hazardous to the non-hazardous location. There is one exception to this requirement of uninterruption, and that's given in subrule 5. It says kind of a quirky rule and a bit over wordy, but it says subrule 5, an uninterrupted conduit run, so they're trying to define what that is that portion of a conduit run which, except for item B, oh my goodness, shall not have any equipment, box, fitting, union T, or similar device installed, and shall be permitted to have conduit couplings. So what subrule 5 essentially is saying is that you can't have anything in the conduit except for couplings. Man, they should have hired me to write that rule. Good grief. Now let's take a look at subrule 4, where a conduit run passes through a zone 1 area without termination. It shall not be required to have an explosion seal, provided the conduit run is uninterrupted. Oh, there's that word again, within the zone 1 area, and the termination points of the conduit are in the non-hazardous locations. So what do you think? Can we have couplings in there? Yeah, you bet. There's one exception, and it's that exception we just looked at, subrule 5. Let's look at subrule 7 and 8, flammable fluid migration seal. So this is required on a cable when it first terminates after entering the zone 1 area. Explosion seals are provided in a cable system where the cable enters an enclosure required to be explosion proof. So here's a junction box that's explosion proof, and here's one of those plastic explosion protected junction boxes. This one only requires a flammable fluid migration seal. This one requires an explosion proof seal. Subrule 9 indicates runs of cable, continuous sheath, either metal or non-metal, shall be permitted to pass all the way through a zone 1 location without seals. And that's a standard tech connector, and that kind of makes sense. How's gas going to get in there, right? It can't, so no seals required. 18108 indicates luminaires for zone 1, and specifically pendant luminaires, because pendant lamp holders are exposed to damage by impact. If damaged, a short circuit could develop, leading to an explosion. Pendant lights must have bracing to prevent movement from an impact or a flexible fitting. And so there's a couple of rules in there indicating what you would need to do. To get away from this, you could just do surface mount lights with no pendant. 18110 is flexible cord for zone 1, and when necessary in zone 1 locations only. To determine the suitability of the flexible cord, ensure to check table 11 for its type designation. And what I'm referring to is this, which will be printed on the side of the jacket, indicating if it is rated for extra hard usage or not. Flexible cords require similar connectors as what is used for tech cable. These connectors are designed for the type of cable used and come in sealable or non-sealable varieties. Zone 2 is not as hazardous as Zone 1, but it's still dangerous. If we go to 18150, lots of electrical equipment is permitted, and Table 18 is again referenced. We're going to take a look at some of the rules within Zone 2 prior to going to Table 18. 18110 equipment subrule 1 states, obviously, as we've seen with the first two zones, electrical equipment installed in Zone 2 shall be in accordance with Table 18. And this will be all the HAZLOC graded equipment that we have grown accustomed to. So here is a cross-section of a whole bunch of the different types of equipment available and suitable as per Table 18. Subrule 2 indicates, notwithstanding, That's essentially saying there is an exception. They're saying there's an exception and the following shall be permitted. This is an exception which indicates that more equipment is permitted than what is stated in Table 18. This equipment does not require HAZLOC certification. These devices do not generate arcs or sparks and is therefore of little risk. Note the equipment must comply with 18054, which would be the surface temperature. So let's look at item A, transformers, solenoids, coil. All of these items here, they don't create arcs or sparks, and they would need to have a temperature rating that aligns with what the gas environment is. Some of the wiring methods in this rule are HAZLOC certified, others are not. Down here, this equipment is not HAZLOC certified, but permitted in Zone 2 applications. Type 4, 4X, IP65 are outdoor rated enclosures. This is sufficient protection for the gas hazard present. And so junction boxes such as this would be prevalent, and we can see that it would have to be containing a non-arcing, not heating, something like that. So junction boxes. Equipment such as motors may cause overloads during normal operation, and so they have a few specific indications here regarding the type of fuses that would be used if we're locating them in a Zone 2 location. They need to be current limiting, and they might have so current limiting and filled, so filled with a sand mixture typically. They can have an indicator or no indicator, and the indicator simply means that it shows you when the fuse is blown. Non-filled fuses would not be permitted. If we take a look at the addition to item E, motors, generators, and other rotating electrical equipment of the open or non-explosion proof type. So that stuff is acceptable as well. So three-phase motors do not generate arcs or sparks or contain heat-producing components. This type of motor does not need to be certified for HAZLOC when installed in Zone 2 locations. Now, there is some caveats to this, obviously, except as permitted by 3 and 4. They can't incorporate arcing, sparking, or heat-producing components. So a three-phase motor would be okay. There's no brushes, but a wound rotor motor or let's say a single-phase motor, all of those would have brushes and centrifugal switches, which could cause sparking. If the motor contains arcing, sparking, or heat-producing components, the components inside must be rated for Zone 1 application as per 18100. So let's take a look at a few motors here. So this motor motors are required to be rated for HAZLOC if they cannot fulfill the requirements. So this cannot fill the requirements, and due to that, it has stamped on it, this is an explosion proof class 1 div 2. It's rated for hazardous location use. Another type of interesting piece of equipment that we can encounter is machines that contain anti-condensation heaters. Now, there's a few little noted items here. Condensation heaters are used inside large motors and generators to prevent moisture from accumulating inside the housing. The heaters are energized between motor runs or even when the equipment is in storage. They can take the form of just a small heating element such as this in a very large piece of equipment. This is a large wound rotor concrete mill. And this is a really expensive motor pump assembly. And what you can see is that it has a separate nameplate for the anti-condensation heaters. And it says the circuit is live when the motor is switched off. Here are the connections. There's the volts and the wattage. So if we have something like this in a hazardous location, it needs to be rated for the application. So this is being sold actually, and you can see even in storage, there's an extension cord here, and the extension cord is plugged into the anti-condensation heaters. Finally, what else referred to with machines and motors? Well, machines referred to in several 2 item E that contain a sliding contact shaft bonding device. What the heck is that? Well, it's a device used for the purpose of maintaining the rotor at ground potential. And it says it has to be evaluated and authenticated by someone with humongous amounts of responsibility with a calculation. Now, where would you use this? Well, motors operated by VFD have increased exposure to harmonics. Harmonic distortions introduce a charge onto the motor's rotating shaft. The electrical potential will discharge through the bearing assembly to the motor frame, damaging the bearings and obviously causing a spark. Sliding contact bonding equipment creates equipotential from the motor shaft to the frame. And so that could look like this, where we have almost like a brush that encircles the shaft and it's a metallic brush. Or it could be something like this, a carbon sliding contact, which simply makes contact with the rotor of the motor. Wiring methods for zone 2 are extensive. There is a ton of them. It says it has to be threaded rigid metal conduit, hazardous location cables, and then, oh my goodness, all of these different types listed. Now, these different types of cables and conduit come in many different forms. Here are the different types of cable. Tech cable is copper, double jacketed. ACWU is aluminum conductors, and then only a single rubber jacket on the outside. Tray cable is rubber, outside quite thick and intended to be laid in cable trays. CIC cable is control and instrument cable, and this usually has shielding and it's very small conductors, and they have a drain line in them. Fire alarm system cable, so armored cable that's used for fire alarm system wiring. It's essentially red BX with fire alarm cable inside, and RC90 cable, which would be a rigid type of interlocking external metal armor, and then a rubber jacket. There's also different types of conduit that are permitted, and we can see here RTRC, not extremely common. It would have to be type XW for industrial application. And then we have liquid type flexible metal conduit and connectors marked for heavy duty use. Now 18152 is going to be the same as zone 1. And this is stating that all of these forms of conduit and cable, if they're going into an explosion-proof enclosure, they need to be threaded for the connection to the conduit and cable glands. 18152.3 indicates same as zone 1. There's two different types of threading. And 152.4 indicates same as zone 1, you need adapters. 152.5 indicates install the cable properly, dummy. And 18152.6, boxes, fittings, and joints need not be explosion-proof or flame-proof, except as required by the rules of this section. And this is simply a reminder that not everything is required to be explosion-proof. It's somewhat obvious, but helpful for clarifying some of the confusion from previous editions of Section 18 of the CEC. So let's continue on. Subrule 7, same as Zone 1. If you're entering into an increased safety E, you need to use a Myers hub. 152.8, explosion or using intrinsically safe. You can use types of wiring methods that are not listed in subrules 1 to 4. So that's handy. And then we get to sealing for Zone 2, which is covered under 18154. Now, a little bit of contrast here. When we're doing Zone 2 locations, explosion-proof enclosures are permitted to be field drilled for additional entry points. The possibility of danger due to user inconsistencies in field drilling is considered low, since Zone 2 is the least dangerous gas atmosphere. The process of field drilling and tapping involves significant attention to detail and adherence to manufacturer recommendations. Subrule 1 indicates explosion seals are required in conduit, where the conduit enters an enclosure required to be explosion-proof. And it then states that we need to have the seals as close as practicable, no further than 450 millimeters from the enclosure, or 50 millimeters if we have done a field drilled entry. And so here's the difference in distances. This rule requires seals on explosion-proof equipment regardless of there being components that are arcing or sparking. This may seem more restrictive than Zone 1 locations, if you remember back to some of the previous rules. But remember, most equipment within Zone 2 locations will not be explosion-proof. 18150 permits many types of equipment that are not explosion-proof and are therefore far cheaper to acquire and install. Subrule 2 indicates the use of flammable fluid migration seals. The conduit leaves the Zone 2 location with no box, coupling, or fitting in the conduit run between the seal and the point at which the conduit leaves the location. So a flammable fluid seal, shown here, is permitted inside or outside the location, and you'll notice that it states very specifically, we are not permitted to have couplings within these locations. So then what would be the maximum distance? And to answer that, we need to know a little bit about how rigid metal conduit is manufactured. It comes in 10-foot lengths. Since the rule prohibits couplings, the logic is that the maximum distance from the boundary a seal would be is slightly less than 10 feet. So to put this in more pictorial way would be to say, well, really like 9 foot 6 inches. This is by not an exact measurement, but I'm saying generally speaking, this would be the maximum you could go. There is an exception, of course there's an exception, a rigid unbroken conduit that passes completely through a zone 2 area with no fittings less than 300 millimeters beyond each boundary need not be sealed, provided termination of the unbroken conduit is in non-hazardous areas. So there we go, non-hazardous and, fittings uninterrupted. Well, what do you think? If we go to Appendix B, it'll tell us a little bit of information to help clarify if we can put couplings in this conduit. So it states here, this is the long rule Appendix B citation. For the application of Section 18, rigid metal couplings are not considered fittings. CSA standard for rigid metal conduit couplings is this, and the standard does not require HAZLOC markings. So to answer our question, uninterrupted, distance is unlimited because you can have couplings in the conduit. So you can have like 5 sections of conduit. Let's continue on. Item B, the conduit leaves the zone 2 location outdoors, in which case the seal shall be permitted to be located more than 300 millimeters beyond the zone 2, shall be permitted to be located more than 300 millimeters beyond the zone 2 boundary, provided that it is located on the conduit before the conduit enters an enclosure or building. Whew, that's quite a bit. So what it's saying here, we can either do inside something like this, right? 9 foot, 6 inch max, or we could go outside, and there's no maximum distance given here, no maximum distance. And that's because it states, provided it's located on the conduit before the conduit enters an enclosure or building. So it continues on until it enters into something else. Now, Appendix B, 18-154, Several 2, Item B, provides a little additional information on why this requirement is a little bit different when we're going to an outside location. And you can take a look at that when you have a little bit of time. 18-154, subrules 4 and 5. Explosion seals are provided on cables when it enters an enclosure that is explosion proof. That makes sense. And subrule 5, where a conduit enters an explosion proof enclosure, it needs an explosion proof seal. Makes sense there again. Finally, subrule 6 runs a cable, each having a continuous sheath, either metal or non-metal, permitted to pass all the way through, no seals. The standard tech connector there, and that's totally fine. 18-156 indicates the same information as zone 1 for luminaires, and 18-158, the same information as zone 1 for flexible cords.